This question is question 4, 11 marks, with a rod being held by a string at point B. So the mass of the rod is m, particle mass is 2m, which is, I wrote it wrong, 1.5 A away from A. So we're going to look at first part, which is which direction frictional force acts. So if you think about it, you've got this force that's holding the rod, and the horizontal force is actually of that string is actually towards the left. So to counteract that, you've got to have the frictional force, which is going to be in the opposite direction to stop it from moving, which will be towards the right. Okay, so just note that down. So, any of these type of questions, that's how you got to look at it. Which direction is the horizontal force and what is the frictional force opposing, because it's going to be in the opposite direction. Okay. Right, second part of the question part B. Okay, now this question's all about showing, proving stuff, so that makes it a bit easier, so you know what you're going to do. Sorry, it's not finding T. Let me cross that out. So we've got to show tension in the string is T, and we're going to show T is equal to 2mg cos theta. All right. So now what we're going to do is looking at moments from point A. Now what we need to do here is we need to look at the actual moments perpendicular to the rod. So you've got the two masses, the mass of the rod and the mass of the particle. So let's have a look at the mass of the rod. It's going to be at the center of the rod. So from point A to the center is A. So so it will be the mass of the rod is m, but that's acting downwards, so the gravitational force is mg, and so you've got to use the triangle to check what is the perpendicular force. Okay, so the angle at the top of that triangle is going to be theta. Okay, and so that perpendicular one is mg cos theta. Okay, so the perpendicular force of the rod is mg cos theta times A. So while we're at it, let's look at the particle. So again, similar thing, angle theta there. Mass of the particle is 2mg, so here the force perpendicular is 2mg cos theta. All right, and to work out the moments, you just have to multiply the distance from point A, or from the point you're measuring, so that's what we're measuring from. So from the rod is mg cos theta times A, and as I mentioned, for the particle, it's going to be that's 1.5 A. So it'd be 2mg cos theta times 1.5 A. Okay. So let's write that down. I thought, to know whether that angle is theta at the top of the triangle or at the bottom of the triangle or so, and just look at the triangle with a theta in it at point A. You can see if that's theta, the one for that triangle, that would be 90 minus theta, and then that top angle will be theta. So particle will be written down 2mg cos theta times 1.58, and of the string it's just t. So really simple. Now looking at the moments, the rod and the particle are acting in the clockwise direction, and the string anti-clockwise. So if you then equate them, you get t equals the moment for the string is t times 2a. So t times 2a equals mg cos theta times a plus 3mg cos theta. And then you've got 2ta equals 4mg a cos theta and that means t equals 2mg cos theta. Okay, so that's that question. Just tidied up a bit messy. But that's that proof. So fairly straightforward, nothing too complicated in that question. Just again looking at the moments perpendicular to the rod. Right. Part C is saying cos theta equals 3 over 5, and we could probably say sine theta is 4 over 5, you know, that triangle. And what we're going to do here is we need to prove that vertical force on ground is 57 mg over 25. Okay. So now what we're going to do is just look at the vertical forces of the object, right? So there's a vertical force from the string, and there's which is upwards, which is going to be t cos theta. Okay, so that's that vertical force. Okay, that's upwards, and then we need to work out the so actually while we're there, t equals 2mg cos theta from the previous example, so we know then the force acting up from the string is 2mg cos squared theta. Now we're going to look at the downward forces of the rod. Again, middle of the rod is so it would be acting down, which will be mg, and the particle will be 2mg. Very simple, no angles, no trigonometry. So then you know the downward force is 3mg, the upward force is 2mg cos squared theta. And then you can say the force acting up on the ground will equal to mg plus 2mg, because it's got to oppose it, mg plus 2mg minus 2mg cos squared theta. Okay, so that's what we're going to come to, and now you're going to get into a nice and simple part. So you know cos theta was 3 over 5, therefore be 2mg times 9 over 25. Okay, write that down, and then you just got 3mg minus that, so then you got basically make everything over the same denominator. So 3mg will be 75 mg over 25 minus 18 mg over 25, which will be 57 mg over 25. Okay, right, so that's that part done. Moving on to the next part. Right, so the next part is another proof. So show mu, which is frictional coefficient is 8/19. So you know the force on the ground is 57 mg/25. So let's look at the horizontal forces. So the horizontal force on the string is T sine theta. Okay. And you know cos theta is 3/5, so sine theta is going to be 4/5. So, you know, something quite simple. And we know what T is, because we just worked that out. It's 2 mg cos theta from earlier. So then you've got 2 mg sine theta cos theta, or cos theta sine theta. Nice and simple. And you substitute cos theta equals 3/5, sine theta equals 4/5. So you end up with 2 mg times 12/25. Okay. So that is the horizontal force of the string acting towards the left. Actually, I drew the arrow the wrong way around, but you know what I mean. And then the frictional force is going to be mu r, and we know r is 57 mg/25. So we substitute that in there. And then it becomes fairly easy now from this point onwards. So 57 mg/25 times mu equals 24 mg/25. And you can cancel out the 25s, divide or multiply both sides by 25. And you can get rid of the mg's as well. You're left with 57 mu equals 24. Mu equals 24/57. And then you divide to, simplify that, divide by 3 both top and bottom, and you get 8/19 for mu. And that is it. That's all right. Okay, thanks. Have a good one.